All right, in this one we got imaginary blubber boy. Is going to jump up from the edge of a 15-meter high cliff with an initial speed of 3.5 meters per second. Then he wants to know how long does it take him to reach the bottom of the cliff, where he becomes a pile of goo. Blah blah blah. Blubber boy. So let's start with this 15-meter high cliff. That's our displacement. Again, it's vertical, so I'm putting in the subscript. You fell 15 meters, so it's negative. He jumped up with an initial, so that's positive 3.5 meters per second. If he had jumped down, you would say negative 3.5 meters per second. If he had just fallen off the cliff, then it's 0 meters per second. How long does it take? So we're looking for t. And again, it's a free fall problem, so the acceleration is due to gravity. So we know the acceleration is negative 9.8 meters per second squared. Just like the previous problems, again, what do they not mention at all is VF. So we want to pick an equation that doesn't have VF. We don't know how fast he hits the ground. It's not we don't need to know. We have enough information to find t without finding the VF. So we're gonna pick an equation that doesn't have VF in it, which is d equals VIT plus 1/2 GT squared. D we know is a negative 15, so that you fell 15 meters. The VIT, this is what sets this problem. We've done a problem like this already, but here's the math gets a little tricky with this one. The VI in the previous one was 0, so that T went away, but on this one, I forgot what it was, 3.5. So you have a number here, 3.5 T. That T does not go away. Plus 1/2 negative 9.8 T squared. Now right now we have a T and a T squared. You can try to divide that T out. It's just going to go to the other side. You're still going to have two T's. There's no way to get rid of those two T's. You can try factoring, but these aren't the nicest numbers, so I would not waste your time trying to factor. If it jumps right out at you, go with factoring. But what this is going to turn into, I'm going to simplify this down. 1/2, I'm going to rewrite it to 1/2 negative 9.8 T squared. That's a negative 4.9 T squared plus 3.5 T. Add the negative 15 to the other side. So I got plus 15 equals 0. It's the quadratic, or it is a quadratic. And how you can solve that is using the quadratic equation is one option. Because this might be more clear, is really ax squared plus bx plus c equals 0. So a is 4.9, b is 3.5, and c is 15. And then the quadratic equation's on your equation sheet. So you could look it up and do it that way, but if you remember your math, we could also just graph it. Take this equation, go into your graphing calculator and enter it in the y equals. So take that equation and just enter it in the y equals button. The calculator is going to spit out a graph. Something like this, usually around that shape, parabolic. And then what we can do, again, if it's been a while since you would have done this in a math class, but if it's been a while, ask each other, help each other. But what you can do is you hit the second calc key, and then I forget what option it is. I think it's the second option. So second calc. This is for a TI. Second calc, and then the 0 option. You want to know where it crosses the x-axis. So you want to know where the vertical is 0. And that'll tell you, these are your x values. So that's one x value, that's the other x value. So in our case, x is the time, or represents the time of the projectile. Well, in this case, blubber boy. But we can already eliminate one of these points. The negative point, we can't go back in time. So the negative time isn't going to be relevant to us for this problem. We need to find this point right here. That'll give us our answer for how long blubber boy's in the air before he reaches the bottom. So we type in our equation, negative 4.9 t squared plus 3.5. Now instead of t, you can do the x. you can just hit that X key as a shortcut. Make sure the negative signs are right, because it will mess up this problem if the negative signs aren't right. You fell 15 meters, so it's negative. Gravity's always negative. And the 3.5 was positive because we jumped out. If any of those change, you need to make sure the signs correctly changed in the calculator. So we're going to hit second calc, hit the 0 option. It's going to do the left bound, right bound. So you're going to take that pointer and put a mark somewhere, hit enter. Then that's your left bound. Take it down below, that's your right bound. Best guess, just leave it where it is and hit enter. It's going to say x equals, in this case, 2.1 seconds. It's going to say 2.1, but the unit, we're in seconds since we did everything in seconds. And then it's going to say y equals 0. So that's telling you where it crosses the axes, where your x value is representing our time. So he fell for 2.1 seconds.